Welcome to solverfy.
Our magnetic field, B, is 5.26 Tesla, and the temperature of the black body, T, is 80 millikelvin, which I convert into Kelvin. So for part A, it says to evaluate the size of the quantum jump in the electron's energy. So the energy of the quantization, which we're calling E sub A here because it's for part A, is equal to the charge of the electron times Planck's constant, h bar, divided by 2 times the mass of the electron times the magnetic field, B. So E, h bar, and m sub E are all just constants. We're using SI units here. And plugging in our value for B, this gives us a value of 97.56 times 10 to the minus 24 joules. You can convert this from joules to electron volts. Since 1 joule is equal to 1.6 times 10 to the minus 19, or 1 electron volt is 1.6 times 10 to the minus 19 joules, this comes out to equal 609 times 10 to the minus 6 electron volts, or 609 micro electron volts. You can write it as 609 times 10 to the minus 6 electron volts, or you can write it as 609 micro electron volts. We can box it in as the solution to our question for part A. Part B wants us to find the energy from the black body that's available from the black body. So we're going to call this E sub B for part B. So this is equal to Boltzmann constant times the temperature that we were given. Plugging these values in, we find that this is equal to 11.04 times 10 to the minus 25 joules. Converting this into electron volts, this comes out to equal 6.9 times 10 to the minus 6 electron volts, or 6.9 micro electron volts. For part C, we're asked to find the frequency of and the wavelength of the photon from the electron absorbed as it jumps to its second energy level. To do this, we're going to use the energy from part A, E sub A, and the equation of that the photon is equal to Planck's constant, h, times the frequency, f. So since Planck's constant has units of joule seconds, we want to use the joules version of E sub A, so the 97.56 times 10 to the minus 24 joules. Plugging that in, we find that the frequency is equal to E sub A over h, which comes out to equal 147 hertz. Now that we know that, we can find the wavelength. Since it's light, so it's going to be traveling at the speed c. Wavelength is just the speed c, 3 times 10 to the 8 meters per second, divided by the frequency. So therefore, wavelength, since we now know the frequency, comes out to equal 2.04 times 10 to the minus 3 meters, or 2.04 millimeters. Which we can box in as the second part of our solution for part C and the final part of the question.